Example 1. Verify that tangent squared plus 1 over 1 minus sine squared is equal to secant to the fourth power. All right, let's first start with the more complex side. That's the idea here, is start with the complex side. Okay, start with the complex side. That's the idea. It's always easier to go from complex to simple. Now, the first thing I know is from those strategies that we pointed out just a second ago, is I can try any of these things. I want to look for a Pythagorean identity here because I see the squared with a 1 here. So I'm going to go to the Pythagorean identities and look for, when I have a sine squared, it's this identity. This is the only one of the Pythagorean that has a sine squared. So I'm going to try this formula here. So when I pull this back up, I'm going to use the formula that sine squared theta plus cosine squared theta equals 1, except for I want it to be 1 minus sine, which means I would need to subtract this sign there. So if I subtract sine across, what this would give me is that cosine squared theta equals 1 minus sine squared theta. All right, so that's the first thing I'm going to do, is I want to change the bottom. So I would be left with tangent squared x plus 1 over cosine squared x. Now someone might be thinking, why, this is a Pythagorean identity again, why did you not do the Pythagorean identity on the numerator? Because the numerator also had a squared. Well, good catch. We can actually do two Pythagorean identities here. We did the denominator, and let's also do the numerator. If you go back, this one has a tangent squared x and a 1. So that would follow the same rule. I'd look on this for tangent squared, and there it is. This formula chart says that 1 plus tangent squared is equal to secant squared. So when I come back over here, I also have that tangent, they wrote it the other order, 1 plus tangent squared theta equals secant squared theta. And notice that's the exact same thing as what we have up here, that tangent squared theta plus 1 equals secant squared theta. You can just switch the order. So this right here becomes secant squared x. Since they're using x, I'll do that. And so just to get this in order, let me change this over here. Let me go here and erase this. This is, I'm sorry, that was cosine squared theta. Okay, so now we see where these came from. So we did Pythagorean theorem to get from one to the other. Well, what did we do? We used the Pythagorean theorem for both those. Now, cosine squared in the denominator, if we moved it up to the numerator, cosine becomes its reciprocal. Now, what is the reciprocal of cosine? The reciprocal of cosine, if you're not sure, you can go to the formula chart and check. The reciprocal identity, the reciprocal of cosine is secant. Or said another way, if cosine is in the denominator, it's the same thing as secant in the numerator. They are reciprocals of one another. So if I want to do a reciprocal identity here, I would say that this becomes the same secant squared that was there. And it now multiplies times, when this moves up, cosine squared becomes secant squared x. And that answer, when you multiply it, is secant to the fourth x. This would be my answer here. And so we verified that that is in fact, that they are equal to one another. That's what we were set off to do. And we got that by saying that here, I should have written that on the side, is that for reciprocal, let me just do it over here, 1 over cosine equals, and usually on the formula chart you use a theta, equals secant theta. And so that's how I got from moving the cosine squared up and got this. Now, there's one for you to try. See if you can verify this, if you can come to the same conclusions. I would recommend that you can, since we don't have a formula that says 1 plus sign, you can't make this make 1 plus. Subtract the 1 to get started. That's how I would just give you a hint. Subtract this 1 and get started from there. Work from, this leave us with 1 minus cosine squared x equals sine squared x. See if you can figure it out from there.